Hello everyone, very good afternoon. Vineet Mishra here once again with the new topic under the course Crash Course Fast and Furious, that is Kinetics. So today we are just going to cover that is the most important topic in mechanics in kinetics, and the topic is impulse. Under this topic we have to cover what is impulse, what is average impulsive force, what is impulse momentum equation, where this equation is useful, what is the source of this equation, what about the sign convention. All these things we have to discuss under this course. So before starting the lecture, first I want to give a brief introduction about myself, as well as about some features of Unacademy, about the subscription, about the courses, and then directly we will just start. Okay, fine. Then moving towards next slide. About me, a brief introduction. Uh, Vineet Mishra. Uh, I'm IIT BHU alumni, ex-assistant professor, Mumbai University, motivational speaker, life coach, keynote speaker. About the qualification, my qualification is BTech in mechanical and MTech in industrial management. About the teaching experience, that is 16 plus years of teaching experience with India's top rated organizations. And about the performance as a mentor, as an educator, as a faculty, as a director, uh, till the date I produce more than 800 rankers, top rankers in the exams like JIPMA, EMS, NEET, JEE Main, JEE Advanced, as well as in the class 12 board exam. The small introduction about myself. Moving ahead towards the features, why Unacademy is important. Sai, Priya, Ganesh, Shaluka, Radhe, most welcome everyone on the platform. Just be there. First, I'm just going to discuss some important features of Unacademy as well as about the subscription. I will take some time and directly I will go for the topic. Then features, why Unacademy is important and different in positive sense from others. So right now, that is, you can learn live from comfort of your home, unlimited access to all the courses, practice tests are there, batch courses are there, mentorship and guidance are there, exhaustive coverage of the syllabus, regular doubt clearing, as well as answer writing sessions are there, live test series, which is very important just to get the best rank in the NEET exam. Then whatever your educator is explaining you can get in the PDF format. In the PDF format, you can download from the our app or website. Next one is about the courses. How many courses are there and what type of courses are there Unacademy is providing. Then first thing is what, that is, it's India's best educators are there on this platform. If I'm concerned with the NEET exam, then obviously subjects are bio, physics and chemistry. All over India, from pan India, you will get the top rankers, top rated faculties, experience wise, knowledge wise, qualification wise, as well as performance wise. Now on Unacademy we have the two different courses. First one is plus course, second is special classes. Now what is the difference between these two courses, plus as well as special? For the example, just in very rough idea, I'm just going to explain you what are the difference. For the example, one educator is there, clear. Suppose physics, chemistry and bio, three different subjects are there and three different educators are there. That is, for the physics one educator, for the chemistry one educator, and for the bio suppose one educator are there. Okay, then on the platform number of educators are there. For the example, we have, suppose for the physics we have 50 educators, for the chemistry we have 50 educators, for the suppose we have the bio 50 educators, plus more than 50 educators are there, because on the platform approximately 1000 educators are there in the NEET category only. Then if one educator is allotted to take, suppose on the platform 100 lectures, then students who are just going to enroll on the plus course are able to access all the 100 lectures of that particular educator. Similarly, he or she can access all 100 lectures of all the educators, but there is limitation in the special class. If you are taking the special class, class, it means what, it's a free of cost. Then in case of each educator, you can get access only about 25 lectures of each educator. So obviously in plus course, most doubt clearing is there, most clarifications there, most mentoring is there, batches are there. So plus course, just to opt the plus course, you have to get subscription for the special classes. It's a free of cost, you can do without subscription. But at the same time, because I want so that all the students should perform, must perform best in the NEET exam. So if you're just going for the plus course, definitely you can rock in the NEET exam. Then now the question is how any of the students can get the subscription. Then easy steps are there. How to get Unacademy subscription? 5 very simple steps are there. Step number 1, if you're just going through suppose a laptop or desktop, then by using the browser you can open the site, otherwise through app also. Then you will get is what, manage goals. First step. Step 2, after selecting manage goals, you will go to the step 2. Step 2, for what exam you are just going to prepare. NDA is there, CDF is there, CDS is there, J is there, foundation or NEET. For the example, if you are the NEET aspirant, then is what, manage goals, you can select NEET UG. After that you will go to the, you will move to the step 3. In step 3, get subscription, select this, you will move to the step 4. In step 4, you will get the course fee duration wise, for example for the 1 month, 3 months, 6 months, 12 month, or and then 24 month, as per your comfort level, as per your convenience, you can choose. For the example, if one student is having desire to opt 1 year course, then you can select this and continue. At the last step you will get is what, that is payment, final payment. But here one thing very important, referral code applied. So if you are just going to apply referral code, what is referral code? For the example, my referral code is, that is VM live, VM live, that is V for Vineet, M for Mishra live. So if you are just going to place here in case of referral code, that is VM live, then you will get 10% off on subscription. Finally you can payment, whether it's a credit card, debit card, Paytm, rupee, or whatever mode is there. Is that clear? So these are the 5 simple steps are there. By using all these steps, easily you can get the subscription. But most important thing is what, if you want the 10% suppose a discount on your subscription off, or as well as you want the better mentoring guidance, then definitely you must use, that is VM live, that is my referral code, just to subscribe NEET UG course. Is that clear everyone? After that, right now I explained all the things. Now I'm just going directly to the topic, which is kinetics and impulse. Let me check how many students are there. Let me interact first. Sai Priyanka Ganesh is there. Shilu Raidas is there. Then Sri Sheila is there. Yashwant is there. Muskan Yadav, Jay Prakash. Okay, so many students are there. Now I just want to say most welcome everyone on the platform. Right now, I'm just going to start the topic, which is kinetics. And under kinetics, we have to discuss impulse. Is that clear? So in today's lecture, I'm just going to explain very important topic, which is very important as per the exam point of view, as well as fundamental point of view also. So just a minute. Now, impulse. Okay, so topic is under kinetics. In mechanics, kinetics is there, kinetics is there, and in kinetics today I have to cover the topic, that is impulse. I have to cover the topic impulse. Now the question is, what is the impulse? What is the source of impulse? What is the definition of the impulse? What is the formula of the impulse? So many things are there. I know here so many students are there very much aware about the impulse, as well as impulse momentum equation, about the sign convention. So many things are there. But important is what? Number one, what is the source of impulse? That is the first question. What is the source of impulse? From where we can get impulse or impulse momentum equation? Most welcome everyone on the platform. So I'm taking the second slide. Before going directly for the impulse, we must know from where we can get the concept of impulse and impulse momentum equation. So I think everyone is having the idea about Newton's second law motion. Everyone is having the idea about Newton's second law motion. For the example, I'm taking one example here. Suppose one horizontal surface is there, which is smooth. Surface is smooth, okay, and one block is placed, suppose, on this surface having mass m. If you are just going to apply one horizontal force in rightward direction to the block, what will happen? Then as per the, obviously the block will move, it means motion will be there. So as per the Newton's second law motion, we can write that is F is equal to ma. Is there any doubt, anyone? We can write, suppose one block is placed on a horizontal surface, and if we are just going to apply one horizontal force in rightward direction on the block, then definitely in the absence of friction, the block will move in rightward direction. And as per the Newton's second law motion, that is Newton's second law, we have the relation F is equal to ma. Is that clear, everyone? Is there any doubt? Is there any doubt? No doubt. Now let, at the moment, this block is having at t is equal to 0. If I am saying that at t is equal to 0, block is having the velocity as u, and at any time t, block is having the velocity as v. Is that clear? I said is what, that at any time t, block is having the velocity as v, and at the time t is equal to 0, block is having the velocity as u. It means what? Here what we can do, and suppose one thing more we can just mention here, that suppose considering in this case that is force is constant, this force is constant, so what we can do, that is F is equal to ma. At the same time, we are having the idea about the a. What is a here? A is the acceleration. So we know that a is equal to dv upon dt. What is the acceleration? Change in velocity with respect to time. So we can put here, we can place here, F is equal to m into dv upon dt. Is that clear? Then cross multiplying, that is F dt is equal to m dv. Is that clear? Then integrating both sides, suppose t is equal to 0 to t, here velocity is u and v, and I, as I said, I'm just moving on the next page. Then that is same equation I'm writing here, that is F dt, that is 0 to t is equal to, that is m, that is mdv, that is from u to v. Is that clear, everyone? Please respond. You guys are getting my point? You guys are getting my point? Is there any doubt, anyone? Is there any doubt, anyone? Is that clear? So fine. After that, now as I said, suppose if F is constant, if F is constant, it means it will be out from the integral. Then F, that is t, is equal to, that is mv minus u. Finally we got this relation. This relation is called as, that is IME. IME means, that is impulse momentum, impulse momentum equation. And believe me, this is very important tool, very important fundamental in kinetics. By using this impulse momentum equation, we can solve kinetics problems. Okay, now some important points about this, that is what is F, what is t, what is m, what is v, what is u. Clear? Now here, if there is no impact, no collision, is that clear? In case of, that is non-collision, non-collision, if there is non-collision or non-impact case, non-impact case, for the example, there is single object and moving in one direction, in that case, What is u? What is u here? U is the initial velocity. That is initial velocity. What is v here? V is the final velocity. V is the final velocity. What is t here? T is the time. What is m? M is the mass. Now one thing which is very important. What is very important? Let me discuss, because so many students apply the concept but got some doubts. What is this? This is ft. Ft as a sum is called as, that is impulse. Is that clear? That is called as impulse. And what is f here? So f is called as, that is not simply force, that is average, that is average impulsive force. That is very very important. What I said, that is average impulsive force. In this equation, this equation is called as impulse momentum equation, which is very important fundamental tool, fundamental principle in kinetics in solving the problem. And here in the equation, ft as a combined is called as impulse, and unit is Newton second, where F is the average impulsive force. Is that clear, everyone? Is there any doubt? Is there any doubt? Please respond. Clear? Okay, fine. After that, that is u is, I said, initial velocity, v is the final velocity, m is the mass. Clear? And f is the average impulsive force, and t is the time. When all these things are, that is in case of non-collision or non-impact, it means what? This is the case when particle is simply moving in one direction. In that case we can apply this concept. Okay, just let me okay, fine. After that, I'm just moving ahead some more points about this concept. What is more point? That equation is, that is ft is equal to mv minus u. Is that clear? What is important here about the sign convention? What is the about the sign convention? This equation is applicable. This is equation is applicable only when all 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 means, that is f, u and v, that is must be in same direction. That is the most important thing. That is all the physical quantities, means all the vectors physical quantities must be in the same direction. Then only we can apply this fundamental equation, which is called as impulse momentum equation. Is that clear? Okay, one thing more. Suppose is the case, as I discussed, when it's a case of non-collision, non-impact. But for example, where another place where we can see the application of impulse momentum equation. In another thing, suppose if it's a case of, if it is the case of, if it is the case of, suppose that is collision. Is that clear? If it's the case of, suppose collision or impact, suppose one object is there and object is suppose colliding or having impact with any other object. In that case, what we can do? In that case, fundamental will be different. Then in that case, suppose in that case, for the example, what is the case? One ball is there, which is dropped from a certain height, and let height is what? H. This is the surface, which is the fixed surface. In that case also we can apply impulse momentum equation. It's a case of, it's a case of impact of a ball, It's a case of impact of a ball with fixed surface. In that case, what is the concept? Now let, that is here, just before the impact, if velocity is suppose just before the impact, if velocity is suppose, that is here u, and after the impact if velocity is v, in that case if we are just going to apply the impulse momentum equation, again the same thing, that is ft is equal to, that is m v minus u. Is that clear? What is the different here? What is the different here? Here don't write v as final velocity. Don't write if suppose collision is there or impact is there, and if you are just going to apply impulse momentum equation, then don't write that is v as final velocity. Instead of this, write as, that is v. What is v? That is velocity, velocity of the object just after the impact. What? Just after the impact. Similarly, in that case, in case of impact, in case of collision, don't write u as, that is initial velocity. Don't write that is u as initial velocity, because sometime that is confusion creates. So don't write u as initial velocity. What is u? That is u is velocity, velocity just before the impact. Is that clear? Is there any doubt, anyone? Jay Prakash and everyone, all the students, is there any doubt? Please respond. So I just explained all the important fundamentals about impulse momentum equation, from where we can get this equation. The source is what? Newton's second law of motion. And from the Newton's second law of motion, F is equal to ma. This equation, this fundamental is derived, which is Ft is equal to mv minus u. In case of non-impact, non-collision, u is the initial velocity, v is the final velocity. In case of impact or collision, if we are just going to apply the fundamental, in that case, v is the velocity of the object just after the impact, u is the velocity of the object just before the impact, m is the mass, ft as combined, this term combinedly is called as impulse. Unit is Newton second, where F is the average impulsive force. Is that clear, everyone? Let me interact. How many students are there on the platform? So, okay. Muskan Yadav is there, Jayaprakash is there, Yaswant is there, Shilu Redas is there. Fine, everyone. Most welcome. Please keep studying. I think just because of some technical reason, I'm not just able to see the text of each and everyone. Let me once refresh. And after that, directly I will go for the fundamental. Just a minute. Because I'm not getting chat, so I'm not able to interact with the students, what they are texting. Okay, Bittu Raj is there, Mahfouz Alam is there, Sonia Jaswal is there. Fine. So you guys are getting my point. Srija, Hers, Sonia, Mahfouz, Hers, Bittu Raj, Sunil, and everyone. Impulse momentum equation. Right now I am just able to read all the comments. Okay, fine. After that, I'm moving ahead. I'm just moving ahead. What with the some examples right now, I'm just going to explain both the cases when the particle is in motion and suppose without impact case as well as impact case in 1D as well as in 2D. So moving ahead with the examples, explain the fundamentals with the examples. Before the example, one thing which is very important. Suppose any of the student can answer where we can apply this fundamental. where we can apply this fundamental and how we can identify where we have to use this fundamental. So important is what, if you are just going to see the equation carefully, that is ft is equal to mv minus u. This is the impulse momentum equation. So in any of the problem, suppose obviously if any problem is there, obviously the object will have the mass and force, clear. And suppose if there is the talk about the velocity with respect to time, it means you have to concentrate about that is force, mass. These two things are common, but what is important, if there is the relation between v and t, it means suppose we have to find the velocity. One object is there having the mass, force is applied, and suppose we have to find the velocity at any instant, or suppose velocity is given, we have to find the time for that velocity. In that case we can apply impulse momentum equation directly. Is that clear? भाई सिंपल सा फंडा समझ जाओ। ये यार मैंने आप लोग को बताया बच्चा लोग को, ये काइनेटिक्स की एक इंपॉर्टेंट फैमिली है जिसका नाम हम क्या बोलते हैं, दैट इज आई मी। आप याद रखना क्या है भाई इस फैमिली का नाम, आई मी। आई मी क्या है, इम्पल्स मोमेंटम इक्वेशन। अब यार हमने फैमिली का नाम दिया तो फैमिली में कौन होता है, फादर, मदर और बच्चे। तो भाई फादर एफ मीन्स यहाँ फोर्स है, ये भाई फादर है। मदर एम, तो भाई यहाँ पे मदर कौन है, ब्लॉक है। इज दैट क्लियर? ये ब्लॉक है जिसका मास एम है। अब दो बच्चे भी आपको चाहिए तो यार बच्चे ले लो आप, दैट इज एक वी है वेलोसिटी और दूसरा टाइम है। इज दैट क्लियर? तो भाई ये आई एम ई फैमिली है काइनेटिक्स की, बहुत इंपॉर्टेंट फैमिली है, आपके बहुत सारे प्रॉब्लम सॉल्व करके देगी। और यहाँ पे एफ father, then M mother, V and T are two kids. Is that clear? चलो यार अब प्रॉब्लम से डायरेक्टली स्टार्ट करते हैं। तो पहले हम एक सिंपल प्रॉब्लम लेते हैं, ठीक है। तो हम आपको दैट इज नॉन इम्पैक्ट का, नॉन इम्पैक्ट 1D इम्पल्स प्रॉब्लम। एक प्रॉब्लम पहले हम सिंपल लेते हैं और आपको दिखाते हैं कहां पे और कैसे ये प्रॉब्लम जो है ये फंडामेंटल में अप्लाई कर सकते हैं। अब मान लो ऐसा दिया है, ठीक है, एक ब्लॉक है, इस ब्लॉक का मास m दिया है, इस ब्लॉक पे एक फोर्स अप्लाई हो रहा है, सपोज फोर्स इज 10 न्यूटन एंड मास इज गिवन 2 kg। इज दैट क्लियर? ब्लॉक स्टार्ट्स फ्रॉम रेस्ट, इसका मतलब t इज इक्वल टू 0 पे u इज इक्वल टू 0 है। अब आपसे क्वेश्चन पूछता है, क्लियर, क्वेश्चन इज इट इज रिक्वायर्ड इफ एट एनी इंस्टेंट, सपोज फोर्स तो अभी भी यही रहेगा दैट इज कांस्टेंट, एंड सपोज ब्लॉक्स वेलोसिटी विल बिकम 10 मीटर पर सेकेंड, देन व्हाट इज द टाइम? Is that clear? That is the question. Suppose one horizontal surface there, friction is not there, and if one horizontal force is applied on the block and block starts its motion from 0, after some time block's velocity become it's a 10 meter per second. What is the time required to change the velocity from that is 0 to 10 meter per second? Obviously you can see here force is given, mass is given, and u is given, v is given. What is required here? Time is required. Then directly we can go impulse momentum equation. So what we can write, that is ft is equal to m v minus u. Is that clear? What is f here? See here, that is in this case u, v and f all are in the same direction. Is that clear? So we can apply. So ft is equal to mv minus u. What is f here? 10. T we have to find. What is the m? M is 2. And what is v? V is 10. U is 0. Is that clear? So 10 10 cancel. T is equal to 2 second. You can get this answer. Is that clear? This is the example number 1. What type? Non impact. कोई impact नहीं है, कोई collision नहीं है, 1D का प्रॉब्लम है। वन थिंग हो, अब अगर इसी प्रॉब्लम को थोड़ा सा और हम बढ़ाएं, ठीक है, थोड़ा सा और इसका लेवल ले जाएं, तो अभी हमने इसको बताया दैट इज क्वेश्चन नंबर 2। ये भी 1D का प्रॉब्लम है, 1D का ही प्रॉब्लम है, 1D दैट इज इम्पल्स। अब अगर एक प्रॉब्लम में थोड़ा सा हम चेंज करते हैं, चेंज ये कर दिया हमने, जस्ट इमेजिन करो कि यार इसका मास अभी भी 2 kg है। अब यहाँ पे फ्रिक्शन आ गया, क्या आ गया, फ्रिक्शन आ गया। फ्रिक्शन दे दिया कि म्यू एस इज इक्वल टू म्यू के इज इक्वल टू 0.1, इतना दे दिया। अभी भी इस पे सपोज हम अगर फोर्स अप्लाई कर रहे हैं, ठीक है, अब इसमें हम फोर्स अप्लाई कर रहे हैं सपोज 10 न्यूटन का, इज दैट क्लियर। एंड लेट द ब्लॉक स्टार्ट इट्स मोशन फ्रॉम u इज इक्वल टू 0। आपको ये फाइंड आउट करना है, क्वेश्चन में ये बोल दे फाइंड द वेलोसिटी ऑफ द ब्लॉक, फाइंड द वेलोसिटी ऑफ द ब्लॉक एट t इज इक्वल टू 2 सेकेंड। अब भाई ये फाइंड आउट करना है व्हाट इज v2, द क्वेश्चन इज डिफरेंट, इज दैट क्लियर। अगेन यू कैन सी f is given, m is given, clear। In this case t is given, f is given, m is given, t is given, what is required, v is required। Again we can use ft is equal to mv minus u, we can use this fundamental directly, is that clear। But here the things are different, here friction is there। So first in any of the problems, suppose if friction is there, then first we have to check whether the block will move or not। So how we can check whether the block will move or not, तो पहले आप लिखोगे to check whether block will move or not। भाई पहले ये भी तो चेक करना है ना कि ब्लॉक मूव करेगा कि नहीं। अब ये कैसे चेक करोगे, तो यार अब यहाँ पे मैंने सबसे पहले एफ मैक्स फाइंड आउट कर दिया कि ब्लॉक और सरफेस के बीच में मैक्सिमम फ्रिक्शनल फोर्स अवेलेबल कितना है, आपको पता है दैट इज म्यू एस इंटू एन, म्यू एस 0.1, एन इज इक्वल टू कितना होगा एम जी, एम कितना है दिया है 2, जी कितना है 10, इज दैट क्लियर। तो ये हो गया 20, तो एफ मैक्स मिल रहा है 2 न्यूटन। भाई 2 न्यूटन का ही मैक्सिमम फ्रिक्शनल फोर्स अवेलेबल है और आप कितने का अप्लाई कर रहे हो 10 का। इट मींस व्हाट, यहाँ पे एफ रिक्वायर्ड, ब्लॉक को रोकने के लिए जो रिक्वायर्ड फ्रिक्शनल फोर्स है उसकी वैल्यू ज्यादा है एज कंपेयर टू व्हाट, मैक्सिमम फ्रिक्शनल फोर्स अवेलेबल। इट मींस आप क्या बोल सकते हो कि ब्लॉक विल मूव, ब्लॉक क्या करेगा, ब्लॉक विल मूव करेगा। ओके अब आगे बढ़ते हैं। अब अगर ब्लॉक मूव करेगा तो आपके पास क्या है, दैट इज इंपल्स मोमेंटम इक्वेशन, एफ टी इज इक्वल टू एम वी माइनस यू। अब इंपल्स कौन कौन देगा यार, हियर यू विल गेट द इंपल्स बिकॉज ऑफ द एक्सटर्नल फोर्स एज वेल एज बिकॉज ऑफ द फ्रिक्शन। इट मींस दैट इज एफ minus that is frictional force into T is equal to mv minus u। Why I am writing here that is minus ft, because I said is what, this impulse momentum equation is useful only when all the vector physical quantities are in the same direction। Now if the force is applied, obviously F is in rightward direction, frictional force will oppose, that is leftward direction, obviously velocity rightward direction। That is the reason, just to make all the vector quantities in the same direction, we can change the direction of F as minus F in rightward, is that clear। that is the reason, so F is equal to y 10 minus that is mu n, here mu s is equal to mu k, same thing। so this one T we have to find, what we have to find here, we have to find here, क्या हमको फाइंड आउट करना है, यहाँ पे हमको फाइंड आउट करना है कि ब्लॉक का वेलोसिटी t इज इक्वल टू 2 सेकेंड पे कितना है। भाई इसको हमने 2 कर दिया, इज इक्वल टू मास 2 दिया है, वेलोसिटी आपको फाइंड आउट करना है और u 0 है, क्लियर। तो दिस माइनस म्यू 0.1, n की वैल्यू कितनी आई 20, n की वैल्यू आपकी 20 है, इंटू 2 इज इक्वल टू 2v, देन 10 माइनस 2, 10 माइनस 2 into 2 is equal to 2v, then finally you will get that is 8 into 2 is equal to 2v, 2 cancelled, it means you are getting v as 8 meter per second। that is the answer, is that clear everyone, is there any doubt, please respond। if you guys are having any doubt then you can tell, I can repeat it again. Right now, I'm just explaining the fundamental. That is application of impulse momentum equation in case of 1D, where there is no impact, no collision. I hope two examples I have taken. One is for the smooth surface and second is for the rough surface. Okay. Now, next question. So, that is question number 3. What I'm just going to explain here, this is most important, fundamental as well as question. This is the case of, that is impulse impulse impact problem. Impact problem. What is the meaning of impact? Impact means what? Suppose if two objects are there and colliding to each other, in that case how we can apply the concept, this is very important. Now suppose one example I am taking, that is one surface is there, clear, this is the fixed surface, and suppose one particle of mass of weight, suppose that is weight is given 0.2 Newton, is dropped from a height of from a height of, suppose that is 10 meter. Is that clear? 10 meter. A particle of weight 0.2 Newton is released, is dropped from a height of 10 meter. Clear? On a fixed surface. That is the question. And rebounds to a height of 8 meter. Then this is coming, hitting here, and then rebounds to a height of, that is 8 meter. That is 8 meter. In that case, what is required? Suppose we have to find, and one thing more it is given, and the average force between the particle and the floor. आपको find out क्या करना है? You have to find first thing, you have to find number 1 impulse, number 2 that is the average force between particle and floor. These two things are important, we have to find. And one thing is there here, that is if the time during which they are in contact, time of contact is given, time of contact is given as 1/10 of a second. This is given. I think everyone got the question. What is the question? Is that clear, everyone? Please respond. Please respond, everyone. Is that clear? Okay. Let me interact about the students. So, this question we are just going to solve. Let me check. I don't know what is there. आज थोड़ा सा मतलब बच्चों का चैट बॉक्स दिख नहीं रहा. दीपक शर्मा, नो डाउट. ओके फाइन, चलो भाई, अभी बार बार रिफ्रेश करना पड़ा तो मुझे पता चल रहा. 8 मीटर पर सेकेंड, 2 सेकेंड. चलो बच्चा लोग रिप्लाई कर रहे हैं भाई. थैंक्स अ लॉट एंड मोस्ट वेलकम ऑन द प्लेटफॉर्म. प्लीज आप बने रहिए. अब इस क्वेश्चन को आई थिंक सभी बच्चों ने देख लिया है. अब लोग हम क्या करते हैं, हम लोग इस प्रॉब्लम को सॉल्व करते हैं. ठीक है. सो एवरीवन इज रेडी. Everyone is ready. Okay, so ready. I'm just going to solve this problem. You know, in this case we can apply impulse momentum equation. So impulse momentum equation is what? That is Ft is equal to mv minus u. Clear? You have to find impulse means Ft, and then you have to find average impulsive force as F. These two things you have to find. You have to find Ft and you have to find F. F is the average impulsive force. What we can do, just please be careful here. Here, as I said, is what? In case of impulse impact problem, here don't say, don't understand as usual meaning, that is u is initial velocity and v is final velocity. No, u is velocity of the object just before the impact, v is the velocity of the object just after the impact. In that case, what is the velocity just before the impact? So we can write here just before the impact. Just before the impact. Suppose we have to find the velocity. So we are just writing here. We know the relation, that is v square is equal to u square plus 2gh dropped, so 0. So we can write here, that is, suppose I am writing here v1 h1 term. So v1 is equal to 2gh1. So v1 is equal to under root 2 into 10 into 10. Is that clear? Is there any doubt, anyone? Is there any doubt, anyone? So here we can write V1 is equal to, we are getting approximately, that is 14 meter per second. 14 meter per second. Moving on the next page, it means, that is, what is this? This is U. Velocity of the block just before the impact, direction is downward, and we are getting the magnitude as approximately 14 meter per second. After that, we have to find velocity just after the impact. Just after the impact. What is the velocity just after the impact? For that, we are considering the upward motion. So that is v square is equal to u square minus 2gh. We can write here v2 u2 s2. In that case, finally rebounds up to height of, that is up to height of 8 meter. It means what? At the highest point, velocity will be equal to 0. It means here, that is u2 is equal to, that is under root 2g s2. It means under root, that is 2 10 s2 is 8. So finally u2, that is the velocity just after the impact. हम इक्वेशन में क्या लिखते हैं? ft is equal to mv minus u. What is v here? That is, v is the velocity just after the impact. It means, that is, v is equal to u2. We are getting approximately, that is 12.6 meter per second. What is about the direction? This one. Is that clear? It means, you can see here, what is important here, that is here u, velocity of the particle just before the impact, magnitude 14, direction downward, velocity just after the impact, that is v is equal to 12.6 meter per second, and direction is what? Upward. Is that clear, everyone? But what is important here, in writing the any of the kinetics fundamental or equation, what's about the sign convention? Then फाइनल जिस डायरेक्शन में ऑब्जेक्ट फाइनली जा रहा होता है, उसी डायरेक्शन को हम पॉजिटिव लेते हैं. हमने क्या बोला? दैट इज फाइनल डायरेक्शन ऑफ मोशन ऑफ द ऑब्जेक्ट इज कंसिडर्ड एज पॉजिटिव. तो भाई ये बताओ, फाइनली ऑब्जेक्ट किधर जा रहा है? फाइनली ऑब्जेक्ट अपवर्ड जा रहा है, तो अपवर्ड एज पॉजिटिव. अब इक्वेशन अप्लाई करने जा रहे हैं. अब देखो, फर्स्ट आपको फाइंड आउट करना है इंपल्स. तो इंपल्स इज इक्वल टू एफ टी इज इक्वल टू एम. एम भाई कितना दिया है यहाँ पे? एम इज इक्वल टू, दैट इज 0.2 इसका वेट है, तो इसको 10 से डिवाइड कर दिया, इनटू v कितना है? व्हाट इज द वेलोसिटी जस्ट बिफोर द इम्पैक्ट? What is the velocity just before the impact? ये आपका 12.6 है और अपवर्ड दिया है इसलिए पॉजिटिव लिया. माइनस what is the velocity just before the impact? ये 14 दिया है बट डाउनवर्ड है इसलिए ये प्लस हो जाएगा, that is 14. After solving these two, you will get ft is equal to approx value. You are getting 0.54 Newton second. Is that clear? Is there any doubt? क्लियर है सभी को? फाइनली ओके. तो एक आपका भाई ये आंसर आ गया, ये आपको मिल गया इंपल्स. अब अगर आपसे पूछता है व्हाट इज द एवरेज इंपल्सिव फोर्स, तो F इज इक्वल टू 0.54 अपॉन व्हाट इज द T? T is 1/10. It means what you will get? That is 5.4 Newton. That is called as average impulsive force. Is that clear? So this is also I just covered, and which is very important, fundamental. So till the time I just covered three important problems. First one you can see, that is non-impact 1D impulse problem. Clear? With the mu is equal to 0, means here in this case mu is equal to 0, means for the smooth surface. Next one is with the suppose here with the friction rough surface, where mu s is equal to mu k is equal to 0.1. Next problem, this is the same thing. Next problem we did is what? That is most important impulse impact problem, where collision is there of the one object with another object. Approach is different, but I explained the fundamental. I am expecting every student got the fundamental. Any doubt? Any doubt? Anyone? Please respond. If you are having the doubt, then please tell me. Okay. After that, what we can do? Next problem. One more problem, uh, which is based on the same concept, but is what? 2D. So that is impact. Now see, that is impulse, impact, 2D problem. 2D problem. What is fundamental here? That is here 2D problem. It means what? Suppose what we can do here, in this case, suppose it is given 1 Newton ball is ball to a batsman. Is that clear? एक बॉल है जिसका वेट दिया है 1 न्यूटन. क्लियर? बैट्समैन की तरफ थ्रो करते हैं. द वेलोसिटी ऑफ द बॉल वाज 20 मीटर पर सेकंड हॉरिजॉन्टली जस्ट बिफोर द बैट्समैन हिट इट. इट मींस क्वेश्चन इज, एक बॉल लिया हमने, ठीक है, इस बॉल का वेट दिया हुआ है, दैट इज वेट इज गिवन, दैट इज 1 न्यूटन. क्लियर? इस बॉल को बैट्समैन की तरफ थ्रो किया विद द वेलोसिटी, वेलोसिटी दिया हुआ है दैट इज 20 मीटर पर सेकेंड. अभी क्या होता है, ये बैट्समैन यहां पे है, सपोज बैट्समैन इज देयर, बैट्समैन इज देयर, और ये उसका बैट है, एंड इसके बाद ये इसको हिट करता है, बॉल को हिट करता है. फाइनली आफ्टर द इंपैक्ट ये बॉल जो है एट एन एंगल 30 डिग्री जाता है, और दैट इज लेफ्टवर्ड डायरेक्शन में, एट एन एंगल 30 डिग्री विद द हॉरिजॉन्टल, एंड वेलोसिटी दिया है इसका सपोज 48 मीटर पर सेकेंड आफ्टर द इंपैक्ट. व्हाट द क्वेश्चन? यार बच्चा थोड़ा बना दे, नहीं आपको लग रहा है कि बच्चे की एक ही आंख है, ठीक है, थोड़ा स्मार्ट बच्चा लो आप. क्लियर? I think everyone got the concept. What is the question? What the concept? Okay, so before the impact, ball velocity is given along the horizontal axis. After the impact, ball's velocity is given at an angle of 30 degree with the horizontal. Question is, that is, okay, if it is given time of contact, if time of contact of ball with the bat is, it is given, suppose that is 0.02 second. If time of contact of the ball with the bat is 0.02 second, what you have to find? You have to find the average force exerted on the ball by the bat. You have to find, that is average force exerted by the bat on the ball. That is the question. Is that clear? What is important here? That is, as I said, that is 2D problem. That is 2D problem. So we can't apply just in one direction. Impulse momentum equation. So just to get the solution, just to get the answer, we have to apply impulse momentum equation, but in two direction. Clear? In along the x-axis, along the y-axis. It means along the horizontal, along the vertical. Because whatever average force is there which is applied by the bat on the ball, that is at an angle. It means what? That average impulsive force will have one component along the horizontal and another component along the vertical. So we have to apply IME once along the horizontal and once along the vertical. But about the sign convention, that is very important. I said is what? The direction of motion in which finally object is moving, we have to consider as positive. So that is the sign convention. Upward as positive and suppose leftward as positive. Let that is x, that is y. So I am writing here applying IME. IME means impulse momentum equation, that is along x axis. ठीक है, as per the sign convention. Then what is the equation in general? That is f of x into t is equal to m v minus u along x axis. So f of x into t, what is the time of contact? That is 0.02 is equal to m. That is weight is given 1, though 1 upon 10 v. What is v here? Velocity just after the impact. So you can resolve here. That is 48, that is cos 30, and this one is 48, that is sin 30. So you can write here, after the impact, what is the velocity in leftward direction along the x? That is 48 cos 30. Left is positive, so 48 cos 30 minus velocity of the ball just before the impact, that is 20 meter per second, but in rightward direction. It means will be minus minus plus, that is 20. Is there any doubt? After solving this, you are getting as f of x is equal to approximately 314 Newton. Direction is what? Leftward, because we are getting fx as positive. Is that clear? Next thing, what we can do, then applying once again, applying IME. IME means impulse momentum equation along y-axis as per sign convention we considered. Then f of y into t is equal to m v minus u. Is that clear? F of y we have to find. What is t here? T is 0.02 is equal to m. What is m here? That is 1 upon 10 because weight is given. What is v? What is v? Just after the impact, that is 48 sin 30 minus what is the velocity just before the impact along the vertical? 0, because at before the impact particle is moving in rightward direction horizontally. It means after solving this, we are getting f of y as approximately, that is 122 Newton. And what's about the direction? Because we are getting as positive, it means that is upward. So finally we are getting f of y as 122 Newton upward, and we are getting f of x as, that is 313 Newton right, leftward. So resulting force F will be this. Is that clear? That is also f of y. This will be the force. What is the magnitude? So F is equal to under root f of x square plus f of y square. It means under root, that is 313 square plus 122 square. After solving, you will get the magnitude of average impulsive force as, that is 336 Newton. That is the answer. Is there any doubt? Please respond. Is there any doubt, anyone? No doubt? Okay. So these two concepts I explained. One more concept I can explain you with one example. Suppose on the inclined plane. That clear? One more example you can see. That is the question. Suppose one inclined plane is there. This is the inclined plane. Clear? And one block is placed on this inclined plane, and weight is given. Weight of this block is given as, that is 130 Newton. That is the weight of this block. Slope is given 5 vertical to 12 horizontal. That is the slope. 5 vertical to 12. It means that is 5, that is 12. Slope is given here, and its initial velocity down the incline is 2.4 meter per second. It means in this case initial velocity at t is equal to 0, u is given, that is 2.4 meter per second down the plane. It means block is coming down, and what will be its velocity in 5 seconds later. It means you have to find velocity at t is equal to 5 second. You have to find velocity at t is equal to 5 second, and coefficient of friction at contact surface is 0.3. It means that is not a smooth surface. Mu is given, that is 0.3. In this case we have to find the velocity of the block at t is equal to 5 second. Again we can apply what we can apply here. In this case we can apply here, that is impulse momentum equation. Is that clear? So applying, that is IME, applying impulse momentum equation. Now the question is why we are applying this impulse momentum equation. Simple thing here because we are applying because F is given, M is given, and T is given, and we have to find V. As I said is what? These are the family members. Which one? Force, mass, टाइम एंड वेलोसिटी. भाई एक फैमिली मेंबर है और इनमें से कोई एक फैमिली मेंबर मिसिंग है जिसके बारे में इंफॉर्मेशन चाह रहा, तो हमको फैमिली के पास ही तो चलना होगा. फैमिली के पास जाओ, आपको आंसर मिल जाएगा. Is that clear? That is the reason. अच्छा, one thing more. All these problems, whatever we just completed here, all these problems we can solve by using the Newton's second law of motion as well as by using the work energy principle also. Is that clear? Any of the kinetics problem you can solve by using three different approaches: impulse momentum equation, that is IME, then WAP, that is work energy principle, and Newton's second law of motion. Then why three different approaches are there? What are the advantages? What are the drawbacks? What is important here? Suppose if it is given, force is given. Is that clear? Mass is given, time is given, and velocity is required. If you are applying IME, you will get the answer in one step. But instead, if you are just going to apply work energy or Newton's second law of motion, your steps will be more. It means what? In the exam, you will take more time to solve. And in the exam, just to do right is not important. Important is what? Just to do right in right time, in faster time. That is the most important. It means you have to identify the nature of the problem, where in which case we have to apply impulse momentum equation, where we have to apply work energy principle. Obviously here forces are given, mass is given, time is given, and velocity is required. That's the reason we can apply here impulse momentum equation. Okay, so in this case, what is sine theta? Sine theta is equal to, that is 5, that is 12. कितना आएगा? Anyone who can tell? That is 13. That is this one, this one. Is that clear? Then you can find here under root 12 square plus 5 square, that is under root 144 plus 25. Is that clear? That is 5 4 9 4 2 6, and this, what is this? Under root 13 169 13. It means sine theta is equal to 5 upon 13, then cos theta is equal to 12 upon 13. Is that clear? So what we can write here and how we can solve this problem? Simply, that is, you can see here block is going down. It means what? Here weight component is there. So on the next page we can write weight component, that is mg sine theta. Is that clear? Will provide the impulse. Then because block is going down, so frictional force will work in upward direction. Is that clear? This one is what? That is mu, k, and n. What is n here? Where n is what? N is equal to, that is mg cos theta. Is that clear? So this weight component will provide the positive impulse, this friction will provide the negative impulse. Is that clear? And so we can write Ft is equal to mv minus u. So F is what? That is mg sine theta minus F, frictional force, into T is equal to mv minus u. What is the velocity here at the start of the motion? That is given 2.4. That is 2.4 mg sine theta. Weight is given as 130 Newton. So directly we can write 130 into sine theta minus F, that is 0.3 into n, that is mg cos theta, into T. What is T? T is given as, that is 5 second. 5 is equal to m, that is weight is 130 upon 10, that is v minus 2.5. After solving this, you will get the velocity as, that is approximately 7.68 meter per second. That is the answer. In that manner, you can solve this problem and you can get the answer. Is that clear? So everyone, I just in today's lecture I completed fundamental of impulse momentum equation, as well as what is impulse, what is average impulsive force, where we can apply this fundamental, what's about the sign convention, why we have to use or why we should use impulse momentum equation in some special cases. So I can say is what, that is the impulse momentum equation is the most important tool, most important fundamental, most important application of kinetics, where we can use, suppose in any of the problem is force is there, mass is there, velocity is given, time is required corresponding, or suppose time is given and corresponding and we have to find velocity. In that case we can apply this important fundamental. So thanks a lot. On tomorrow at the same time I will come on the same topic, but with new, some important, some shortcuts, some logical problems. Thanks a lot everyone, and thanks a lot on the platform. See you on the lesson, see you on the in the next lecture. Thank you.